everybody, and welcome to the fourth episode of this series where I teach you how to build a redstone computer. Last time I talked to you guys about logic gates. This episode we will use it mainly in how to store bits. That's what this episode is about. So, to be more precise, first, I'll teach you how to build an RS NOR latch. If you don't understand it, don't worry, I'll explain it in a minute. Then, how to add the enable function. And at last, I'll show you my design for storer. Now, before we make any kind of circuit in Minecraft, I'll go back to Paint, because that's a lot easier to explain. So, see you guys there. So, to store bits, we will need to make use of latches. Now, what is a latch? A latch is just a combination of different logic gates, and with a latch you can store bits, and that's what we need. You can also do other things with latches, but that's the most common use. You have different kinds of latches, and the one I'll be showing you today is the RS NOR latch, and it stands for reset set NOR is a NOR gate. So, as you might have guessed, this latch makes use of a NOR gate, and you might recognize it with my terrible drawing skills that this is a NOR gate, the OR symbol and a little circle at the end. Now, what is special about this is that the output from the first NOR gate runs into the input of the other, and vice versa. And that is what allows me to make a latch, allows you to make a latch. So let's first look at the truth table for the NOR gate. The OR, as you might remember, is the output turns on if either one of the inputs are on. So in this case, 0 and 1 is on, so this should be a 0, 1. This one is on, so that's 1. They're both on, that's also okay, so this should be on. Here there is none on, so in an OR gate that should be 0, but this is a NOR gate, so you invert the the outputs, and then you get 1, 0, 0, 0. Like you see, if they're both 0, then it immediately turns to 1. So the first one you build will automatically turn to 1. So for example, you build this one first. This is 0, and this is 0. Then this will be a 1. That means this will also be a 1. And here there is 0 and 1. 0 and 1 is 0. So this will be a 0. Now, if you push this button, if you turn this to 1, nothing will happen. Because if this is a 1, then it's 1 and 1 stays 0. But if the other one becomes a 1, this will be a 0 still, then suddenly 0 and 1, 0 and 1, that is a 0. So this can't be a 1 anymore. That means this will be a 0. But now here it's 0, 0, which means that this will also be a 1, and this will also be a 1. And even if you turn this line back to 0, then still here there is a 1, and here there is a 0, but because there is a 1, the output stays a 0. So it basically flipped, and that's one of the most common things you'll see in a latch, and that's what it allows to store bits. So now you see we stored something here. Now there are still a lot of problems with this design, because here you have two inputs, we only want one input, and here you have also two outputs. The input one is a little bit more tricky, but the output is very easy. We just, to narrow it down to one, you just get rid of one of the two lines, or you just don't take an output from that anymore, and you just take the other one. Now this, which one you need to pick depends on where you put the NOT gate that will be here. But before we do that, let's go first into Minecraft, and I'll show you how to build this in Minecraft. Now that you understand the concept, here I've built the circuit in Minecraft. So here you have the OR gate with the NOT gate at the end. Same here. A few repeaters so the signal is extended and the lines don't run back and screw the system. It won't happen with this NOT gate anyway, but still for the extending from the line. And here you have two output lines, and both of them go back into the other NOR latch right here and on top. So this one I built first, so you see that that line is on. If I push this one, nothing happens. To illustrate the point better, I'll put some repeaters here as well. But if I push this one, beam, it switched. And this one again, switched, and you get the picture. Just like I showed you last time. Now this is quite bunky, so this is another design for a Minecraft. It works a little bit different, but it does the same. So these buttons are the two outputs, and these redstone lines, these buttons are the two inputs, and these redstone lines are the two outputs. Now if you push this one, where the torch is already off, nothing will happen. But if you push this one, it will switch. Now how does this work? Well, it also runs into the other gate. So if you push this one, here it's already powered, so nothing will happen. But this one, because it's inverted, isn't powered, so it doesn't power this redstone torch, which makes it glow. But if you do power it, it goes off, meaning this redstone line will go on, and it goes back right to the torch itself. And if the power from the button is away, this power line can take over. So this that's how to build a simple latch in Minecraft. Now there are still a few problems with this, like I said, that there are two outputs and two inputs. So to explain how to solve those, I'll go back to Paint. Okay. So then, how do you get rid of the second line? Well, it sounds a bit counterintuitive, but to get rid of the second line, we will need to add a third line, being the enable line. Now, the enable line is a bit different, because it doesn't affect the output of the circuit, but when the circuit needs to fire. What I'm drawing right now is an enable line, so this is the enable line. And these are the two input lines. Now, like you see, here I've drawn an AND gate. What this means is, if this one is 1, the signal will only go through if I also power the enable line. So for example, if I power this line, but this line is not on, then this will stay a 0. But if this one also goes on, then this one will be a 1, this will turn off, this will turn off, and if this is also not on, then this will go on. Now because we have an enable line, we can tell the circuit when it needs to copy the first line. So for example, if this becomes a 1, this will be a 0 and a 1. But as long as the enable line stays off, both these lines will stay off, because an AND gate only lets the signal through if both lines are on. Now imagine I do push the enable line on, this will stay 0 because 0, but here 1 and 1, that becomes a 1. The 1, that means this will become a 0. So this will become a 0. 0 and 0 results in a 1. This is a 1, both 1. And if the enable now goes off again, this one will become 1. But here still the 1 stays on. So this one will stay a 0. And now it's pretty much finished. The only thing we need to add now is get rid of one line. And now because we see this is a 1 and this will also be a 1 and this will also be a 1, we can get rid of this line. Now it's done. So for example, if this will become a 0 again, then this will become a 1, and this will become a 0. And for example, if this goes on again, this will become a 1, this will become 0 because this is 1, so NOR. This will become a 0. These are both zeros. Both zeros become a 1. This becomes a 1, and now it's flipped. And even if this one goes back to 0, then this one goes back to 0, but I'm sorry, this one stays to a 1. It's very messy now, but I think you got the picture. So that's how we build an RS-NOR latch. But of course, this is paint, and we need it in Minecraft. So let's get back to Minecraft to explain my circuit. Now, with all this knowledge put together, I created this module. And it has everything in it that I showed you in paint. This circuit, this little circle, right here and right here, this redstone torch, not this one, and also not that one. This is the output line. Is basically that thing, but vertical, right here. So the latch. This is the output line. This is the input line, and this is the enable line. So how it works: first it runs into an inverter. Why? Because I messed up in designing, and it would, if I wanted to store 0, it would store 1, and vice versa. So I needed to invert. I just picked the wrong output. Then it goes into two lines. Here it has an inverter, if you remember. This one doesn't invert. Then here comes the AND gate. This is a different kind of AND gate where the signal only runs through if the piston is extended and the signal can go through the block. So with this line I can extend the pistons. Now because this is set to 0, it stays 0. Then this area is the most complicated. And yeah, I inverted the line here because I needed to invert it here again, because that was the only way to power this block. This is a little bit more complicated, but this block with its redstone torch is one of the redstone torches, and the other one is, the other one. And then it runs back up, back down, it takes an output from here, and it powers this redstone torch again, which powers this redstone torch again. It's quite complicated, so I'll let you take a screenshot if you want. But if you dig deeper into it, you'll understand that it's actually the exact same, but a little bit different designs. So let's test it. This is 0, and if I push enable, nothing happens. If I flick it to 1, it stores 1. Now nothing will happen because it stayed at 1. If I flick it back to 0, it will go back to 0. It's quite fast. So this is a module I use all the time because it can store bits, it can I also use it to write it to the bus and clear it if I want. That's a cool trick. If you power this line by placing a redstone block here, it will automatically set the output to 0. And then it doesn't look at the input line or the enable line, just always set it to 0. And that's quite handy. And it doesn't break the system either. Now you might ask, why are there here honey blocks and here slime blocks? And the answer is, there is no reason actually. I don't know why I used slime blocks here and honey blocks here. I really don't know. You can use either one, it doesn't make a difference. Don't forget to place the obsidian here and here, otherwise the system will break. So that's how to build a store for bits. So this can store 1 bit, but it's 1 tile. It's not tileable, so you need to leave a space between before putting the next one. But because you made it this far, I want to show you something special. And it's something I found out shortly after designing this whole thing and shrinking it and putting a lot of work into this. And it's another way to make this. And it's just with an inbuilt feature. I'll show it. Look. Done. I am not kidding. It's so simple. Enable, input, and I'll build this monstrosity. I hate it. Look. Oh, I'm sorry. This is so embarrassing. It still works though. It's just you need to invert the enable line. Nothing happens. Bam. Bam. It's so easy. It's not as easy to tile it as well as that one, but I think probably not. It's probably also very easy. But it's so small. It's so damn small. It's the locking repeater feature. Who thought that they would ever use the locking repeater feature? Literally nobody. But here it is. You can turn this thing into that thing. And on that note, congratulations if you made it this far into the video, because now you know a very easy way to store bits. And thank you guys for watching, and see you guys next week. Bye!